Addition and subtraction with fractions requires the same denominator in the fractions you're adding or subtracting. So let's start by looking at some problems where the fractions have the same denominator. I've written up here 2/7 plus 3/7. I'm going to rewrite each of these fractions this way. We know that dividing by 7 is the same as multiplying by 1/7, so I'm going to write this as 2 times 1/7 plus 3 times 1/7. We can do that with fractions whenever we want. Dividing by 7 and multiplying by 1/7 exactly the same thing. So now when I look at it this way, I can say to myself this: well, I have 2 of these 1/7 here, plus another 3 of these 1/7 over here. That gives me a total of 5 of these 1/7, and that comes out to be 5/7. So that's just kind of to show you why it is that 2/7 plus 3/7 comes out to be 5/7. Why we add the numerators, but we don't add the denominators. The denominator just stays the same, and as a matter of fact, has to be the same in both cases. Now, to go this step right here, if I wanted to show another step, I could show the distributive property. This is the same as 2 plus 3 times 1/7 using the distributive property, and so you can see that that would be 2 plus 3 is 5 times 1/7. Or just think of it as 2 of these things plus another 3 of the same thing. That's going to be 5 of those things. In any case, that gives us a reason to write our rule for addition and subtraction with fractions this way. A over C plus B over C is A plus B over just C. So the requirement is that the denominators in both fractions are the same, and that's the same denominator that shows up in the answer. A over C subtract B over C, same idea. The answer will be A minus B, subtract the numerators like that, and put the answer over that same denominator that you had to begin with. So it's a requirement for fractions that we have the same denominator to begin with if we want to add or subtract them. Okay, let's look at 3/8 plus 1/8. Well, according to our rule right here, this is going to be 3 plus 1. I'll add numerators, put that over that same denominator that I had to begin with. I'll simplify now, 4/8, and then I'll reduce to lowest terms by dividing out that common factor of 4, and I end up with 1/2. So adding fractions when they have the same denominator, pretty simple process. Here's one more problem that has both subtraction and addition. I'll just extend my rule here to just say, well, as long as the denominators are the same, I can just take care of the addition and subtraction in the numerator. So this will be equal to 3 subtract 2 plus 9, all divided by 5. And we know because of the rule for order of operations that we have to do addition and subtraction left to right. So 3 subtract 2 is 1, plus 9 is 10. All divided by 5, and then that will simplify down to just 2. So adding and subtracting fractions when the denominators are the same, pretty easy process. Let's take a look at what happens when the denominators are not the same. Let's start with 1/3 plus 5/6, a couple of fractions with different denominators, okay? And I say, well, okay, let's see if I can make this fraction into a fraction that has a denominator of 6. So what I'm going to do is this. I'm going to take this 1/3 and I'm going to change it a little bit. I won't do anything with the 5/6, but what can I do to this 1/3 right here where I won't change the value of it, but I'll end up with a fraction with the same value but with a denominator of 6? Well, the answer is I can multiply it by 1 in the form of 2 over 2. So this number right here is just the number 1. So I know if I multiply 1 times 1/3, I'm still going to get 1/3. But look, when I multiply 1 in the form of 2 over 2, I'm going to end up with 1 times 2 is 2 over 6 plus 5 over 6. And I think you know that, right? You know that 1/3 and 2/6 are exactly the same thing. I did this because I can't add these two fractions unless they have the same denominator. So this problem, 1/3 plus 5/6, is the same as this problem, 2/6 plus 5/6. Now I'll just add numerators and get 2 plus 5 is 7, divided by that common denominator, 6. Okay, so Again, the number 1, very important here, because I know if I multiply a number by 1, I won't change its value. I'm changing its form, but not its value. How about 1 plus 1/2? I'm going to add these two. I'm going to think of the 1 as a fraction. I know it has to have the same denominator as my other fraction, which is 2. So how about if I just write this problem as 2 over 2 plus 1 over 2? Isn't this still the number 1? Sure it is. So 2 over 2 plus 1 over 2, I'll add numerators. 2 plus 1 is 3, and put that result over my common denominator 2. So anytime you have a whole number like this, like 1, and you want to add a fraction to it, you can think of that 1 as 2 over 2, or 3 over 3, 5 over 5, 7 over 7, whatever's convenient. In this case, it's convenient to think of it as 2 over 2 because I'm adding it to 1/2. Okay, how about 5 plus 3/4? 5 plus 3/4. Well, I want to write 5 as a fraction with a denominator 4. So what number what fraction has a denominator of 4 and a value of 5? Well, if you think about it for a little bit, you'll see, well, how about if I write 5 as 20 over 4 plus 3 over 4? Isn't 5 the same as 20 divided by 4, or 20/4? Sure it is. So I have 5 plus 3/4. I'll add numerators. 20 plus 3 is 23. I'll divide it by 4. So we're just doing this kind of intuitively. We don't have a method. The only thing that we really know is that we can't add or subtract fractions unless we have the same denominator. So that's our goal, and then we just use whatever kind of things we know intuitively to get us to that point. 1/8 plus 2. 1/8 plus, well, if I'm going to add this fraction to another fraction, that other fraction has to have a denominator of 8. But I can't change the value of the 2. It still has to have a value of 2, but also be written as a fraction with denominator 8. So what should the numerator be? 16. 16 over 8, that's the same as 2, so here's my problem, 1/8 plus 2. But now, at least I can add the 1 and the 16, get 17 over 8, and there's my result. So next what I want to do is take a couple of little more harder problems and see if we can't develop a method for finding a common denominator regardless of what the fractions look like to begin with, so we can take whatever our original problem is, change it to an equivalent problem with fractions that have the same denominator regardless of what denominators we start with. Let's go to the next board and check that out. Here we have a couple of fractions that have different denominators. This one has a denominator of 5, this one has a denominator of 3. In order to add these two fractions, we have to change them to equivalent fractions that have the same denominator. So what I look for is the smallest number that's divisible by 5 and also divisible by 3. So when you think about this for a minute, what's the smallest number that's divisible by 5 and also divisible by 3? Well, the answer is 15. The least common denominator is going to be 15 because 15 is 3 times 5. So I know that 3 divides 15 5 times, and 5 divides 15 3 times. So now I want to change my two original fractions, 4/5 and 2/3, into fractions that have the same value but have the denominator 15. Well, when I look at this denominator 5 and I want to end up with the denominator of 15, I know I have to multiply this by 3 over 3. That will give me a denominator of 15, but since I'm multiplying by the number 1, I know I won't change the value of this fraction. Likewise over here, I know that I have to multiply by 5 over 5 because 3 times 5 will give me 15, and since this is the number 1, I know I won't have changed the value of my original fraction. Okay, pretty easy after that. 12 over 15 plus 10 over 15 is going to give me 22 over 15. So when I add 4/5 and 2/3, the result is 22/15. Okay, and again, in this problem, the most important number is the number 1. Let's look at this problem, 5/12 divided by 7/18. Okay, I can't just tell by looking what the smallest number is that's divisible by 12 and divisible by 18. So I'm going to build my least common denominator by looking at the factors of each of these denominators. So to find my least common denominator, I'm going to start with 12 and factor it into the product of prime factors. Factor it till I can't factor it anymore. 4 times 3 is 12. That's 2 times 2 times 3. 18. Okay, 18 is going to be 2 times 9, so 2 times 3 times 3. Now, I want the smallest number I can find that's divisible by 12, which means it has to have factors of 2, 2, and 3. And I also want it to be divisible by 18, so it has to have factors of 2, 3, and 3. So let's build the least common denominator from these fractions, from these denominators. First of all, I need all these factors, so 12 divides it. 2 times 2 times 3. Now I know, as long as I have those factors, 12 divides that least common denominator. I want 18 to divide it also, so I know that I need a factor of 2. Well, I have that. There's my 2. I need a factor of 3. Well, I have that. There's my factor of 3. I need another factor of 3. I only have one factor, so I'll put in another factor. So this number right here, which is what, 4 times 9, or 36, is the smallest number that's divisible by 12, and 12 divides it 3 times, and it's also divisible by 18, and 18 divides it 2 times, right? 2 times 18 is 36. Okay, so we're all set. I'm going to rewrite this as 5/12 times, I know I want 36 here. Here's my 12. What I need is a factor of 3. So I'll multiply by the number 1 in that form, plus 7 over 18. Okay, I know I want a 36 here instead of an 18, so I'm going to multiply by 2 over 2. That gives me 15 plus 14, all divided by, in both cases, 36, which ends up being 15 plus 14, 29 over 36. So there's a lot of ways to go about doing these problems. This is probably the simplest way when you get the least common denominator. If you don't get the least common denominator, you just get a common denominator. It still works. The number 72 will work because 72 is divisible by 12 and by 18. It's just that you'll end up with larger numbers here and you'll end up having to reduce to lowest terms. So finding the least common denominator instead of any common denominator actually saves you some time in the long run. So here's the point. We can only add fractions that have the same denominator. If we get a couple of fractions and they don't have the same denominator, we have to change to equivalent fractions, fractions with the same value that have that denominator. And again, when you look at all these problems with addition right here, what number is the most important number? Again, it's the number 1, because that's what allows us to change to equivalent fractions that have the same value as our original fractions, but now have the least common denominator we're looking for.